In this video, we are going to rewrite each expression with positive exponents. And our goal will be to write each expression in their simplest possible form. Okay, let's start with this one, x power negative 1. This x can be written as x divided by 1. Now this power negative 1 is included for both the top x and the bottom 1. And remember, we learned from the negative exponent video that from the negative exponent, if we give the negative alone to the base will be reciprocal. Therefore, reciprocal of x divided by 1 is 1 divided by x and whole power 1, which is just 1 divided by x. Since any number power 1 is that number. And we can also think like this. If you bring a term from the numerator to the denominator or vice versa, then the sign of the exponent will only change. Like if the exponent is positive, then it becomes negative. If the exponent is negative, then it becomes positive. Moreover, there is a special name for putting a little negative one. That's called multiplicative inverse. So, x power negative 1 can be read as x inverse. And like x inverse is 1 by x, y inverse is 1 by y, 5 inverse is 1 by 5 and so on. But not for 0, because multiplicative inverse of 0 is undefined. Rarely in algebra is there only one way to solve your problem. Don't be concerned if the steps you use to solve your problem are not exactly the same as the steps presented in our videos. The important thing is to use steps that you understand and, of course, steps that are justified by the rules of algebra. Now let's look at this one. 1 divided by 3x power negative 2. Here in the denominator, x has negative exponent. In order to write it with positive exponent, let's bring this x power negative 2 to the numerator. So we have 1 times x square divided by 3. Because we brought the term from the denominator to the numerator, we change the sign of the exponent. See, it was negative, now it's positive. And after bringing it, multiply it with the one already on numerator. Okay, we get 1 times x square is x square divided by 3. That's it, since we can't go further. Okay, now let's rewrite this with positive exponent. For that, from the exponent, if we give this negative alone to the base will be reciprocal. The reciprocal of 3x square divided by y is y divided by 3x square and whole power 2. The power 2 is for both the numerator and the denominator. So if you distribute the power 2 to the numerator y, we get y square divided by, okay, now let's distribute the power to the denominator. If we distribute the power 2 to the base 3, then it will be 3 square. Next, if we distribute the power 2 to the base x square, we get x square the whole square. So we have y square divided by 3 square is 9, then x square the whole square is x power. Just multiply the powers. 2 times 2 is 4. Since power rule for exponent says that when you have power to the power or exponent to the exponent, simply multiply the powers or exponents. That's it. We're done. Now let's try this one. 12a cube b power negative 4 divided by 4a power negative 2 b. Okay, in this expression, two terms are having negative exponents. One is in the numerator, that is b power negative 4. Another one is in the denominator, a power negative 2. So, first I am going to rewrite the negative exponent terms into positive exponent. For that, I am going to bring this a power negative 2 to the numerator. At the same time, bringing this b power negative 4 to the denominator. By doing so, we get, in the numerator, 12a cube. And if I bring this a power negative 2 to the numerator, it becomes a square divided by 4b. And if I bring this b power negative 4 to the denominator, it becomes b power 4. Now let's simplify. We can cancel the numerator 12 and the denominator 4 by the common factor 4. We get 3 in the numerator. Then here, we can apply the product rule which says that when the bases are same, just write a base and combine the powers. We get a power 3 plus 2 divided by, here also we can apply the product rule because bases are same and there is a multiplication sign between them. So we have b power 1 plus 4 because we know that just b is really b power 1. Hence 3a power 5 divided by b power 5. Now let's try this one. 21a power negative 8 b power negative 3 c power 6 divided by 35a power negative 2 b power negative 1 c power negative 4. Okay, in this expression, 5 terms are having negative exponents. 2 in the numerator, 3 in the denominator. So, first I am going to rewrite the negative exponent terms into positive exponents. For that, I am going to bring this a power negative 8 and b power negative 3 to the denominator, while bringing this a power negative 2, b power negative 1, c power negative 4 to the numerator. Consequently, we get, in the numerator, I just copy the 21 and c power 6 which I didn't use. Then if we bring this a power negative 2 to the numerator, we get a square. Then if I bring this b power negative 1 to the numerator, we have b power 1 or just b. And if I bring this c power negative 4 to the numerator, we get c power 4 divided by, in the denominator I am just bringing down the 35 which I didn't use. Then if we bring this a power negative 8 to the denominator, we get a power 8. And finally, if we bring this b power negative 3, we get b power 3. Let's start simplify now. So what do you think we need to do? We can cancel the numerator 21 and the denominator 35 by the common factor 7. By doing so, we get 3 in the numerator and 5 in the denominator. And c power 6, c power 4 is c power 10. Since bases are same, write a base and combine the powers, 6 plus 4. Then we can cancel the numerator a square and the denominator a power 8. We have a power 6 in the denominator. Since we know that a square is nothing but 2a's multiplied together, while a power 8 is 8a's multiplied together. So by cancelling 2a's both in the numerator and the denominator, we have 6a's in the denominator, which is just a power 6. Likewise, if we cancel the numerator b or b power 1 and the denominator b cube, we get b square in the denominator. And that's it. Since we have rewritten all the negative exponents to positive exponents, and we can't simplify further.